Hi guys, it's Janek from Elympics. Today I'm going to talk about the core part of using Olympics, which is the Olympics update. Olympics update works similar to how update and fixed update work in your normal Unity project. It's where you put the main game loop of your project. As I've mentioned in the tutorial about built-in synchronizers, if you want to synchronize any part of an object, it must have an Olympics behavior component on it. That includes synchronizing the scripts. Using a script that inherits Olympics monobehavior class on an object should add the Olympics behavior component to it automatically. To use the Olympics update, your class must implement the iUpdatable interface. If you put your code inside the Olympics update method, it will run on any instant for which the object is predictable. You can set the predictability in the editor inside the Olympics behavior component, and it cannot be changed at runtime. If you set it to all, the server, as well as all of the players, will simulate the object. If you set it to player, you will give an ID, then the server and the player with corresponding ID will simulate the object. If you set it to none, then the server will be the only instance simulating the object. The invalid option will work the same as none, but in the code it will simulate an invalid value, and it should only be used for testing purposes. As you could notice, the server instance, by design, simulates all of the synchronized objects. If you want something to only happen on the player instances, simply put it in an object that isn't being synchronized, or use the isClient property of Olympics monobehavior. But make sure to not base any crucial game logic on data calculated locally. Unity's update and fixed update have pretty clearly cut roles. The update runs once each rendered frame, while the fixed update operates with set frequency and is used for physics calculations. You might be wondering how the Olympics updates fits in this structure. To understand that, you must first learn a bit about how the Olympics game loop works. The Olympics game loop is based around ticks. A tick is a fundamental unit of time in which the game state is simulated. Each game state is described by a tick number and states of all variables in that tick. The advancement from one state to another happens in the Olympics updates. That is why all synchronized logic should be applied there. Olympics updates will all be called in the order based on their network IDs. Those can be found in the Olympics behavior component. Olympics also uses Olympics updates to simulate and process all physics, although that happens after all other Olympics updates and isn't bound to network IDs. On the server, the loop looks the following way. Olympics collects input from players and bots. All of the Olympics updates are called. Olympics collects the snapshot for the tick we've simulated and sends snapshots to clients. On the client side, the situation is a bit more complicated. The most confusing part about it is that what the client is seeing isn't the current state of the game on the server, but a state a few ticks into the future. Player's input is based on what he's currently seeing, but it takes time for it to reach the server. If the player only saw information confirmed by the server, his input would be given for the tick that has already been calculated. That's why we try to predict how the game will look like a few ticks from now and show that state to the player. This way, input from the player has a chance to reach the server before the tick the player has seen when pressing the button is simulated there. We keep the ticks we've simulated in memory, and when information from the server comes back to us, we compare it to what we've collected in our history and either confirm it, or, in case of finding any differences, override our local information with that from the server, and based on that, try to predict the future ticks again. In the end, it should look something like that. We collect player input, send it to the server, get the latest snapshot from the server. If we find any differences, apply the snapshot onto the tick in our history, recalculate what we've predicted previously, Now, based on newer data and inputs saved in history, save the results of recalculation, then apply parts of snapshot that aren't predictable, call the Olympics updates for currently predicted tick using current input, and save currently calculated snapshot to history. This is a very complicated topic presented in a simplified way, but if you'd like to learn more about it, we encourage you to visit the game loop article in the guide section of our documentation at docs.olympics.cc. That's it for today. If you wish to learn more, we encourage you to visit our website at olympics.cc and to join our community Discord. Links in the description below. Have a great day and thanks for watching!